Hey, this is Mr. Hansen. I'm wanting to talk to you today about two variable statistics. So I'll give you an introduction and then we'll talk a little bit more about it in the later video. So first of all, let me kind of give you a problem situation. We have a graph here across the x-axis that says years since 2016. So this is 2017, 2018, 2019, 2020, and then 2021. So here's kind of where we that's the most recent data is 1 through 4. And across the y-axis it says basketball game attendance in thousands. So in 2016 maybe there was 8,000, and then maybe there was in 2017 maybe there was about 16,000, and then maybe there was about 17,000, and then there was a little jump here to 22,000, and then let's say 30,000. And so we have some data, and each of those data points measures two different things. It measures the year, or the length of time since 2016, and it also measures the basketball attendance. And you can tell they're not all lining up quite right. They're not quite in a straight line. But this kind of graph is called a scatter plot, and it helps us see a trend. It helps us see what's happening. So as you go through the years, you can kind of see an increasing pattern as the years increase or go on. The basketball attendance for this particular team is getting higher and higher. And so not only can you see what's going on there, but you can also, with those data points and using some more advanced math, we use it in a calculator, you can come up with what we call a line of best fit, and it's the line that comes closest to touching all of these data points. So notice one's right on the line, there's one below, one above, and maybe one or two more above or below the line. So that's called the line of best fit. It's the line that comes closest to touching the data points. I kind of eyeballed that one. You actually need a computer technology that would give you a formula for that particular line, and that formula is more than we're going to discuss here today. But the line it's a linear equation, and it has a slope and a y-intercept. And the slope is going to tell you, m, the slope is going to tell you number of the increase per year in terms of basketball attendance. So it's the rise over the run, and it's just the increase in year, or the number of attendant people how many more people attended each year. Sorry about that. And then the y-intercept, so you have y equals mx plus b, and the y-intercept just stands for year 0, kind of close to where you were at. Okay, so that's the line of best fit. Whenever you're given a line on a graph, you know it accompanies an equation, and so we call this a linear regression equation. Regression connotes that we're talking about how far the dots are away from the line, and we're trying to get the data points as close to the line as possible, and the computer formula the formula that's used is computed using computers most of the time. So the linear regression equation is this one here. Notice I'm putting a little hat over the y. They call that y hat, and that means my prediction. Notice at 1 year, my prediction is going to be a little bit lower than the actual data point, and that's something that's important to understand. The regression equation, the line of best fit, they're just giving you an estimate of what's going on. Okay, so what good is all of this? Well, if you have an equation, you can plug in a value for x into that equation, times it by the slope and the y-intercept, and then add the y-intercept, and you can come up with an estimate. And that's kind of a nice thing. Your estimates will be a little bit off, but at least you'll have some kind of an estimate. So if you wanted to, we could kind of continue this line, kind of like this. We could even go backwards a little bit if we wanted to. And you could come up with an estimate. So if we were to take a look at this. I'm drawing a line here and here because our estimates they work a lot better when they're within the range of your data. And this is just the range of our data. We had 0 years, 1, 2, 3, 4 years. And it's probably all right. That's called interpolation, when you make an estimate inside the range of the data. There's probably no new data for us there, really, in this case, but in other cases there might be. But extrapolation is when you make a prediction. Let's say maybe this is 2016 here. Maybe you wanted to make a prediction for 2015, or maybe you probably already knew the data, so that's not that important anyway. But let's say maybe you want to make a prediction a couple years out in the future here, maybe 5 years after 2016, or 6 years, or 7 years, or 8 years. That's okay to do. This is called extrapolation. That's okay to kind of make some of these predictions right out here. But if you go too far, you're running into the problem of maybe over time your trend is going to change. Maybe there's only so many seats in the auditorium, and so instead of going upwards like that, you go up, and then we kind of curve like that. Or maybe the team is just no good, and so they went up and then they kind of went back down. Or maybe the team is better than everybody thought they would be, and people are just really excited, and so maybe in that case you kind of go up and then up even steeper. So there's some different possibilities there that you have to take into account. So using extrapolation, that's when you plug in an x value that's really quite far away from the last piece of data you took, and then you get out a y value. You have to question if this is really that helpful for you, and how accurate it might be given maybe some of the changes in circumstances. So this is just kind of a brief introduction to two-variable statistics. Just to go over it really quickly again, a scatter plot is just a way of plotting ordered pairs, or plotting points that have two pieces of data, so that we can see a trend between the two data items. In this case, it was time since 2016 and basketball game attendance. And once we have all those points, you can put that data into an Excel spreadsheet or a graphing calculator or a computer, and it gives you two things. It gives you a line of best fit, and whenever you have a line, what accompanies a line is an equation. Line of best fit is helpful. It's visual. It helps you kind of see your outputs based on certain inputs. And then your regression equation is even more exact. If you put something in for x, you can predict where on the line it will be for y. And then finally, last but not least, there is one limitation that we talked about in this video, and we'll talk about more in other videos, but the limitation is you really shouldn't extrapolate too far outside of your data, your given data. So if we said 25 years from now, and this line keeps going in the same direction, well, I think by then probably you would have ran out of seats, or something would have happened to change the circumstances and wouldn't be very good. So you have to keep in mind that extrapolation is a little bit dangerous, especially if you go too far away from the number or the data that you've been given. I hope this helps out. Thank you for listening, and have a wonderful day. This is Mr. Hansen signing out.